Isaac Newton and his apple.
A miserable start.
Isaac Newton was born at 20 minutes after midnight on Christmas morning in the year 1642, just a few weeks after his father had died. Isaac had arrived prematurely, and nobody expected the feeble baby to survive until the evening. But not only did he survive until Boxing Day, he went on to live for 84 healthy years. When Isaac was about 1 year old, life in England suddenly changed.
Oh yay, oh yay! Parliament has finally had enough of the king. A soldier called Oliver Cromwell is raising an army of Roundheads against him.
There was some fighting and house burning in Lincolnshire where Isaac lived, but luckily for the Newtons, they missed out on the worst of the Civil War. Instead, Isaac's problems started just after his 3rd birthday, when his mother married a 63-year-old vicar called Barnabas Smith. She went off to live in his parish of North Witham, and little Isaac was left behind with his granny in Woolsthorpe. Poor Isaac. Most of the time, he spent brooding. My real father's gone to heaven, my mother doesn't want me, and my granny thinks I'm stupid. No wonder I'm a moody kid who stares into space a lot. But occasionally he did make his feelings known, and once he even threatened to burn down the rectory where his mother and her new husband lived. Despite his unhappy situation, Isaac started to develop some interests even as a small child, and in particular he was fascinated by sundials. He'd sit for hours watching the shadows cast by the sun moving round, and would mark their positions at set times of the day. The Reverend Barnabas died when Isaac was 10, and his mother returned to live at Woolsthorpe. She brought quite a lot of money back with her, and also her new children, Marie, aged 6, Benjamin, aged 3, and baby Hannah. For 2 years they all lived as a family, and in his early teens, Isaac was a bit of a father figure to the others. But as soon as he was 12, Isaac's mum sent him away to the King Edward VI Grammar School in Grantham. It has to be said that at first Isaac wasn't inspired, and he soon hit the bottom of the class. This doesn't mean to say he was lazy. Indeed, the place he was staying at, Mr. Clark's, the apothecary, that's an old-fashioned chemist, by the way, became very full of sundials. But it was thanks to Mr. Clark's stepson Arthur, the school bully, that one day Isaac's whole attitude changed.
Oi, thicky newt face. We want to kick a ball around.
Leave me alone, Arthur.
You don't understand. You are the ball.
That's it. I've had enough. It's retribution time. What's your problem?
Nothing, Mr. Newton, sir. Got to hurry up. Be late for irregular Greek verbs.
And suddenly Isaac had made a decision. He was going to be superior to everybody he knew in any way he could. Isaac learnt to read and write Latin as easily as English. He also amazed everybody with his ability to build model windmills, water clocks, and other mechanical marvels, often working on Sundays rather than studying the Bible, as he was expected to. Strangely, he couldn't resist drawing on walls. His subjects could be inventions, mathematical shapes, or even portraits of people, including King Charles I, which was a bit dangerous. By now, Oliver Cromwell was running the country, and he'd had the king executed. Cromwell was a strict Puritan, which meant that he wanted church services to be as basic and boring as possible, so that there was nothing to distract people from worshipping. Cromwell wouldn't have been happy about Newton's wall paintings. As well as learning Latin and Greek at school, Isaac spent long hours studying chemistry, maths, mechanics, and astronomy from a pile of books that had been left at Mr. Clark's house by his brainy brother, Dr. Clark. At the age of 17, Isaac was just starting to amaze everybody when his mother said,
Isaac, I need you on the farm.
Needless to say, Isaac was not cut out to be a farmer. He was fined when his pigs broke into a neighbour's cornfield, and he got himself a criminal record. But luckily, his uncle realised that if Isaac could get to Cambridge, his brilliance might not be wasted. And he helped persuade Isaac's mother to let him return to school to prepare for university. In 1661, Isaac got a place at Trinity College, Cambridge. Aged 18, he was about 2 years older than most of the new students, but more to the point, he was a lot poorer, and earned his keep by cleaning the rooms and emptying the chamber pots of the richer students. Cromwell died in 1658, so England had a king again, in the form of the Merry Monarch, Charles II, son of Charles I. It was an exciting time to be at Cambridge, but while most students spent their lives partying, Isaac studied everything he could lay his hands on, often working right through the night. And when he wasn't studying, he was desperately trying to sort out his religious beliefs by making long lists of his sins. When he graduated in January 1665, his brain was race-tuned, supercharged, fueled up, and ready to take on the world.
So, Isaac, what do you really do?
Isaac didn't regard himself as a mathematician or a scientist. Instead, he would say that he was a natural philosopher. Like so many of the great brains before him, Isaac was only using maths and science to find out the answers to really big questions, such as, why do we exist? Where is God? What is everything made of? Quite apart from studying maths and so on at Cambridge, Isaac had 3 other special interests. The Bible. He spent ages analysing the Bible and trying to work out religion for himself. And it wasn't long before he decided that even the Bible itself wasn't so perfect after all. This was going to lead to big trouble. Alchemy. Alchemy was a brilliant subject. It was a sort of cross between chemistry and magic. Alchemists had 2 things they were especially keen to discover. One was elixir vitae, which was a drink to prolong life, and the other was the philosopher's stone, which was a substance so perfect that it had the power to turn boring metals into gold. On the whole, alchemy was fair old rubbish, but like many clever people before him, Isaac took it all very seriously. To help him with his own thoughts, Isaac also studied earlier philosophers. Aristotle was a Greek philosopher and scientist who lived from 384 to 322 BC. One of the main conclusions he came up with was, the Earth is the centre of the universe, and the sun and everything else moves round it. The Earth has to be still. If it wasn't, we'd all fall off. Aristarchus lived about 100 years after Aristotle, and he thought the sun was in the middle of the universe, and everything else, including the Earth, went round it. But hardly anyone took him seriously. In Isaac's time, nearly 2,000 years later, Cambridge was still sticking to Aristotle's ideas, but elsewhere in Europe they were starting to get more and more suspicious. To find out why, we go back to the time of the ancient Greeks.
Nearly all the stars stay in their patterns, but a few of them seem to move. We'll call them planets.
Maybe those planets are gods looking down at us.
I hope they're in a good mood.
Ancient people followed the progress of the planets very carefully, which is hardly surprising. If you thought there was a god in a bit of a touchy mood zimming across the sky, you'd keep an eye on him or her too, wouldn't you? They plotted maps which showed the Earth at the centre of the universe, and they drew fancy patterns to show how the sun and planets seemed to move about the sky. In about 1510, the Polish monk Copernicus found out about Aristarchus's ideas and plotted a new version of the planet's movement with the sun in the middle. Poor old Copernicus was so worried about his version of space upsetting everybody that he locked it up for 30 years. At the end of the 16th century, about 50 years before Isaac was born, a copy of Copernicus's book eventually found its way to the clever German astronomer Johannes Kepler, 1571 to 1630. Kepler was invited to work with the rich Danish astronomer Tycho Brahe, 1546 to 1601, who had an island kitted out with all the best equipment available for stargazing. Tycho also happened to have a nose made of gold and wax, because his real one had got chopped off in an argument. Kepler worked on all sorts of clever stuff, including his 3 laws of planetary motion, which we'll find out about later. Then there was the Italian, Galileo Galilei, 1564 to 1642, Galileo for short. He was rude, arrogant, loud-mouthed, tactless, obstinate, argumentative, and he nicked other people's ideas. But most of all, he was infuriatingly clever. Galileo dropped things out of high buildings to show that the acceleration of falling objects is constant. He also thought that the earth must move, because its movement made the tides of the sea go in and out. Finally came René Descartes, 1596 to 1650. He was a lot more up-to-date and said nature was like a machine. Everything could be measured, and there was a nice, solid, mechanical reason for everything that happened. As it turns out, he pretty much got it right, but not without upsetting all sorts of people who couldn't see how God fitted into his scheme of things. Isaac wasn't happy with the God situation either, but he did realize that Descartes' basic ideas were a lot better than Aristotle's.
A flying start.
In the years leading up to Isaac's time, some handy methods of calculation had been invented which were to be very useful, especially with the murderous maths involved in astronomy. Now, you've probably heard of decimals, but what about logarithms? These are a shortcut to multiplying and dividing complicated numbers. Logarithms also made it much easier to work out powers, which were always jamming up astronomical calculations. Descartes had also invented the Cartesian coordinate system, which is a way of measuring where things are, and this meant people could draw algebra equations out as graphs. So, what's the use of all this? Well, it's got lots of different uses, actually. But most importantly for Isaac, maths equations can be used to describe how things move. After he graduated from Cambridge in January 1665, he spent an astonishing 12 months developing some amazing ideas. First, he developed his binomial theorem, which meant you could calculate logarithms really exactly and so work out extremely complicated sums. Isaac himself got a bit carried away with it and worked out some sums to 55 decimal places. Next, in May 1665, Isaac came to terms with tangents. Now, a tangent is a straight line that touches a curve at one point. At the time, everybody was studying the moon and planets and their paths, trying to work out why they moved as they did. Astronomers spent ages drawing the curved paths of the planets on paper and then wrestling away with fiendish sums to describe what they saw. If they could use maths equations to describe exactly how planets moved, they might understand what was making them move in the first place. Isaac realized that if you look at a planet for a split second, it is moving at a tangent to the curve. Sounds nasty, eh? Well, think of it like this. Let's say that instead of gradually turning a corner, the planet moved round in a set of straight lines. Obviously, as the planet moves along each line, its direction is straight ahead, which makes the sums a lot easier. To make the path of the planet look more like a curve, you can use shorter and shorter lines. As you do this, the path will become a perfect curve. But the point is that even if your lines are only teeny-weeny, they are still straight. If you want to see exactly which direction the planet is travelling at any one instant, all you do is extend the teeny-weeny straight line it's sitting on, and abracadabra, you get a tangent. This led to his next massive discovery, which Isaac called fluxions, but the world came to know as the dreaded calculus.
We interrupt this fascinating mathematical bit to bring you A Spot of Plague, the Stuart Sun, December 1664, late edition. Mystery illness strikes. A woman was found collapsed in the street yesterday, shivering, sweating, and covered in her own vomit. She is believed to be Mrs. Annie Clackett, who discovered 2 French sailors dead in a gutter last week. An inquiry has been opened into the cause of her condition, but rumours of plague are yet to be confirmed.
The public are advised not to panic,
said a government official who examined her.
I'm sure it's harmless.
Fleas from the continent had brought the bubonic plague with them, and by hitching rides on the backs of the town rat population, they quickly spread right through the capital. Just one tiny flea bite was all it took.
The Stuart Sun, January 1665. Government official dead. The official who examined Annie Clackett less than a week ago has been found dead. Further victims have fallen in many other parts of London. Another government official has said,
"It is the plague. We are now advising the public to panic."
Yes, the Great Plague of 1665 was underway, and at the time, no one knew how it was transmitted.
The Stuart Sun, June 1665.
Plague spreads outwards from London.
Thousands of Londoners are already dead, and now victims are starting to die in the provinces. Many towns are being evacuated, and establishments are closing, including the university at Cambridge.
And so, as a result of the plague, Isaac left Cambridge to return to his family. Going home meant that he could really shut himself away and get on with some serious stuff. And as it turned out, Isaac had the most brilliantly productive 16 months. For a moment, let's imagine the back streets of London in 1665. As well as the usual smells and filth, there would be the screams of people dying, the stink of abandoned corpses, and you could well have been the next plague victim. There. After that, going back to calculus doesn't seem so bad, does it?
Calculus, the maths miracle.
To a mathematician, calculus is more useful than a steering wheel to a bus driver. The whole point of it is that you find out answers by splitting things up into smaller and smaller bits until you get a result. In their way, the ancient Greeks had a go at it, especially when studying circles. In around 400 BC, the Greeks tried to find the area of a circle by filling it up with triangles, because it was easy to find the area of triangles and then add them up. Another idea was to enclose a circle with 2 multi-sided shapes, because the area of the circle had to be slightly more than the inner shape and less than the outer shape. But neither calculation could ever be exact. Nearly 200 years after that, the great Archimedes, 287 to 212 BC, decided to concentrate on working out the circumference of a circle. I knew the distance around the outside of a circle can be found by multiplying the distance across its centre by a special number. This special number was given the Greek name pi, but the problem was working out its exact value. Isaac could have used calculus to work out pi, but in fact he wasn't too bothered because just before he was born, people had found other ways to do it. The real reason Isaac developed his calculus was to find out exactly how the tangents change direction along a curve. To work out a gradient, you divide how high you've risen by how far you've walked. Isaac imagined his teeny lines getting smaller and smaller until they were just infinitely small points that couldn't get any smaller. Obviously, the gradient of the curve alters as you move along. What Isaac wanted to figure out was how to make equations that described the rate of change of the gradient. Tons and tons of really mind-bending maths later, he cracked it and developed a system that is now known as differential calculus. Remember, Isaac invented all this so that he could measure gradients at any point on a curve, and more importantly, so he could analyze how the gradient was changing as the curve went along. This gave calculus another slightly different use. You can plot graphs which show how fast things are moving by putting distance along one axis and time along the other. When an object increases in speed or accelerates, the line gets steeper. Isaac found he could link all these things up using differentiation. Bingo! He had hit on a mathematical jackpot. He would soon find that solving problems of acceleration would help him understand why planets moved like they did, and in turn, this would help him to discover the big G. So what did Isaac do next? Did he jump up and down and tell everybody about his discovery? Did he try and sell it? Did he have it tattooed on his bottom? No. Well, of course, we can't be absolutely sure about the tattoo.
Isaac's undiscovered diary.
I've just invented the most useful maths technique in the world, but I am not going to tell anyone. Isaac and his temper couldn't cope with even the merest hint of criticism, and so that's why he didn't tell anybody what he was up to. Besides, he hated the idea of being famous. He just wanted to be left alone to get on with his work. Unfortunately, this still led to a lot of shouting, screaming, and general aggravation. Actually, there was one person at Cambridge who Isaac trusted, and that was his old tutor, Isaac Barrow, who was the first Lucasian professor of mathematics. The job of Lucasian professor was created in 1663, and even today it is one of the most respected jobs in the world. When our Isaac was at Cambridge, it gradually dawned on Barrow that Isaac was an academic diamond. Isaac got on with Barrow, not only because Barrow was good at maths, but because he also had interests in alchemy and religion, worked ridiculously long hours, gave Isaac birthday presents, and most importantly, he was ambitious. Young Isaac knew it would make sense to stick with him. Isaac had shown Barrow some of his work on calculus, and some years later Barrow passed it on to the maths publisher John Collins. Collins wanted to publish it all, but Isaac absolutely refused. Then, years later,
The Stuart Sun, October 1684.
German.
Discovers miracle maths. Gottfried Leibniz has invented an ingenious math system with which he claims he can analyze motion and speed.
I call it calculus.
He said yesterday and added,
I thought it up all by myself. I am indeed a genius.
Isaac didn't allow his own version to come out until 1704, and that's when the dirty fighting really started.
Herr Leibniz says Mr. Newton stole his ideas.
Then Leibniz is a liar.
This sort of exchange went on until Leibniz died 12 years later. But shortly after that, Isaac found out what he had suspected all along. Collins had sneakily shown Leibniz some of Isaac's fluxions work years before. Meanwhile, back in 1665, Isaac is sitting in the garden at Woolsthorpe, avoiding the plague, when high up in a certain tree an apple is preparing to break the frontiers of scientific knowledge.
The Big G.
By this time, Isaac had pretty much read everything worth reading about anything, and made some firm decisions as to what he agreed with and what he didn't. In particular, there were two people whose work he did appreciate and pondered on for days on end. In 1609, Johannes Kepler published his laws about how the planets move. And, of course, as Isaac was dead clever, he understood them immediately, but we might need to take them a bit gently. So, here are Kepler's laws, simplified. 1. As a planet orbits the Sun, it moves in closer, then moves back out again. Instead of just going round the Sun in a perfect circle, Kepler realized each planet moves in an ellipse. That's a shape a bit like a squashed circle. 2. Kepler also realized that while a planet is further away from the Sun, it moves more slowly. But when it's closer in, it moves faster. So, whatever distance it is from the Sun, a line from the planet to the Sun will sweep out an equal area in an equal time. 3. The planets that are further away from the Sun take longer to complete orbits than those that are closer in. Not only do they have further to go, they move more slowly. Kepler had produced an absolutely accurate measure of planet speed, and he was able to describe it in a rather catchy little equation. Poor old Kepler died in poverty, but his brilliance provided some of Isaac's main inspiration, and for that he'll always be remembered. The other person whose work Isaac latched onto was Galileo. Apart from being one of the first people to dare suggest that the Earth moved around the Sun, Galileo's great discovery was that a falling body accelerates at a uniform rate. This is what he means.
This should be high enough. I have a little egg and a heavy cannonball. Which should hit the ground first? I drop them both at exactly the same time. Downward! Phew! Just in time. Just as I thought. Their weights don't make any difference. They land at exactly the same time.
Having realized that different objects would fall the same distance in the same time, Galileo went a step further and realized that when you drop something, it speeds up steadily as it falls. Just suppose you were to drop an elephant out of an aeroplane flying a few thousand meters in the air. After 1 second, the elephant will be falling at 10 meters per second. After 2 seconds, the elephant will be falling at 20 meters per second. After 3 seconds, the elephant will be falling at 30 metres per second. After 4 seconds, the elephant will be falling at 40 metres per second, and so on. You will find the elephant's speed always increases by roughly 10 metres per second every second. This is called constant acceleration. Of course, hitting the ground will affect the constant acceleration as well as making a nasty mess on the floor. Meanwhile, in the garden at Woolsthorpe, Isaac is thinking about why Kepler's laws work. He knows all about Galileo's constant acceleration idea too, but things falling to the ground is a completely different subject from planets flying about the sun. Isaac had no idea that they might be connected, and then the apple fell. Ooh! Why did the apple fall? Because everything falls to earth. So maybe there is some invisible force pulling things to earth. Suppose the tree grew as high as the moon. Would the apple still fall? Why not? So why does the moon not fall to earth? Because good grief, that's it! Admittedly, the moon doesn't fall to earth, but far more importantly, it doesn't fly away. And that's because of this invisible force. What is Isaac talking about? Look at it like this. When the moon is orbiting the Earth, it is trying to pull away, but something is holding it in place. It isn't held on by a piece of string, so what is holding the moon in place? It must be this invisible force. And this force is gravitas. Of course, we call it gravity these days. And people have known about gravitas since Aristotle's time. However, Isaac was the first person to correctly understand what it was. Gravity solved one ancient problem quickly. Aristotle had said that the Earth couldn't be moving, or we'd all be thrown off into space. In fact, if it wasn't for gravity, then yes, Aristotle would have been right. However, on the surface of the Earth, the gravitational force is easily strong enough to hold us on. That's lucky, isn't it? Another thing Isaac worked out is that the strength of gravity gets a lot weaker as you move further away from the Earth. It took Isaac 20 years to refine and correct these ideas before he published them in one of the most famous scientific books of all time, Principia. But let's get back to January 1666. Isaac took a short rest from gravity, and instead his incredible 12 months of brilliance continued when his brain had
a flash of colour.
Up until that time, it was thought that different colours were created by mixing darkness and light. It was a nice idea, but somehow it didn't hang together. Already, Descartes had tried to analyse a beam of sunlight and produce two colours out of it, red and blue. Next, Isaac started to do some experiments on light. These days, everybody knows that you must never look at the sun directly, even if you've got sunglasses on, and that poking sticks in your eyes is generally a bad idea. But Isaac stuck a pointed stick into his eye socket under his eyeball and wiggled it back as far as it would go. This caused him to see several coloured circles, and he wondered where the colour had come from. It doubtless also caused him to feel a lot of pain, but he didn't need to wonder where that came from. Then he spent hours staring directly at the sun to see what effect it would have. The main effect was that he almost blinded himself and had to spend several days in a dark room before his eyesight returned. Once he'd recovered, Isaac more sensibly started experiments passing rays of light through a triangular glass block, or prism. Isaac allowed a thin ray of sunlight to come through a narrow chink in his curtains and hit the prism. The prism bent the ray of light and projected it onto a wall 7 meters away. Most importantly, Isaac noticed the light on the wall made a beautiful spectrum showing all the colours of the rainbow. Up until now, everybody had thought that white light wasn't mixed with any other colours. But then, how had all the colours on the wall come from one beam of sunlight? Isaac realised that white light is not pure at all. It is made up of all the colours of the rainbow put together. Isaac did a lot more experiments on light and colours back at Cambridge. In the meantime, his mind turned back to the problems of the big G, and to help him solve them, he hit on his second maths miracle. While Isaac was battling out the sums involved with Kepler's laws and Galileo's findings, he realised that he needed to take his fluxions a bit further, and so in May 1666 he invented his method of inverse fluxions, better known now as integral calculus. This allowed him to calculate the area under a curve, which would help him do even fancier calculations about how the moon and planets fly about. The simple way to find the area underneath a curve is to split it up into very thin rectangles and add them all up. The thinner the rectangles are, the better the result, and thanks to Newton, we can now work this out using differential calculus. For Isaac, working on how the moon and planets were moving, and in particular for studying Kepler's laws, being able to do these sorts of calculations was utterly fabulous. Meanwhile, in London, the newspapers had other hot stuff to keep them busy.
The Stuart Sun, September 1666. Careless baker.
Cook's City.
On the evening of the 2nd of September, the King's baker, Thomas Farriner, closed his shop in Pudding Lane, failing to ensure his oven fire was safely out. Within an hour, the whole house was in flames. The baker managed to escape with his wife, his daughter, and a servant, but sadly their maid
Perished in the flames.
Within hours, the Great Fire of London was underway. £10 million worth of damage was done as a result of the fire, equivalent to about £6 billion these days. But amazingly, only 16 people actually died in the fire. And strangely, the fire probably saved hundreds of lives, because it got rid of the rats carrying the plague.
Back to Cambridge. Isaac's undiscovered diary.
As a natural philosopher, I must strive to find the true answers to everything. My maths and science progress well, but I am becoming unhappy with the Bible. The more I study it, the more doubts I have. So I have procured some very early versions in ancient Hebrew, which I have translated for myself. It's just as I suspected. It seems that the Holy Trinity of the Father, the Son, and the Holy Ghost is little more than an invention of scholars down the ages. The Trinity is false, as are many other Christian beliefs. Mankind should be praying directly to the one true God, and yet I fear to announce this conclusion. These were very dangerous thoughts. Everybody at Cambridge University was supposed to be Christian. The country had only just come out of a civil war, in which people were killed for the wrong beliefs. So, once again, Isaac kept his thoughts in a secret notebook and didn't dare tell anyone. In October 1667, he was elected to be a Fellow of Trinity College. This was quite an honour, as it meant that people were taking him seriously. It also meant that he got paid wages. Not much, but it was better than nothing. Isaac hadn't been able to resist demonstrating some of his prisms and spectrums at Cambridge, but he wanted to check that his colour experiments were foolproof, so he did some more tests. By thinking about the colours in soap bubbles, Isaac came up with an experiment which involved pushing a glass lens down onto a sheet of glass. This produces an effect that has become known as Newton's rings, and is a much nicer version of what he was doing when he was poking at the back of his eyes. Newton realised that the colours were caused by light being reflected in the tiny gap between the lens and the glass. In a soap bubble, the colours come from the light being reflected within the very thin wall of the bubble. As the gap got narrower, so the colour of the light changed. All Isaac's work with prisms helped him come up with a rather useful result. Some years before, Galileo had taken the credit for inventing the first telescope, although in fact he'd pinched the idea. And after that, Kepler had invented a better version. By the 1660s, people were starting to use bigger and bigger telescopes to look at the sky. Some were over 60 metres high and used massive arrays of lenses. The trouble was that distant stars always looked a bit fuzzy round the edges, and smaller objects only appeared as faint smudges. This is because lenses work by refraction, which means they bend the light as it goes through them. But Isaac's prisms showed that when you bend white light, the different colours in it bend by different amounts. Red bends the least, and the bluer colours bend the most. Isaac decided to try and make better telescopes. And it's interesting to note that he did all the work himself. He was an extremely skilled craftsman. His first thought was that he should try making telescopes with some extra lenses that were specially shaped to cancel out the colour problems. But then he thought about it night and day until he hit on a better solution, one that revolutionised telescopes forever. Instead of lenses, he used a curved mirror, because he found that when light bounced off the mirror, the colours didn't split up at all. Isaac finished his first reflecting telescope in 1668. It was only 15 centimetres long and less than 3 centimetres wide, but it made things look more than 30 times bigger. It was more powerful than the old refracting telescopes that were 10 times the size. The Newtonian reflector was to change Isaac's life. The powerful little telescope was a gadget that anybody could have fun with, and nobody who saw it could deny that it was a pretty smart bit of kit. For once, Isaac didn't mind showing off his invention, and when he did, the world was impressed.
Isaac gets horribly famous.
In 1668, Isaac was promoted in the university to a senior fellow, which meant better wages. For about the only time in his life, he relaxed to celebrate with his old college friend Wickens. They went to the pub a few times, they gambled at cards, and Isaac even changed his image with a posh set of new clothes. This didn't last long, though, and soon he was back, working harder than ever. "I'm just popping out to do another 25 years solid work."
Typical. Just when it was your turn to buy the drinks.
People were starting to realise that Isaac was a bit special. In the autumn of 1669, his old tutor, Dr. Barrow, gave up the job of a Lucasian professor of mathematics and insisted that Isaac took his place. But as Lucasian professor, you were supposed to be a fully ordained Church of England priest, Many others in Barrow's place would have had Isaac kicked out of the university for not being religious enough, but Barrow insisted that Isaac should take the role without having to become a priest. The professorship brought good wages, and the opportunity for Isaac to follow his own studies, but he was also expected to give 10 lectures a year. Now, Isaac's lectures were not a success. The students who did turn up were soon put off when he started droning on about how he thought everything worked. People used to sneak away, leave him warbling on his own. And it wasn't long before nobody turned up at all. His lectures got shorter and shorter, but as they were part of the job, he carried on talking to empty rooms for almost 20 years. When word got out about his telescope, Isaac Newton became quite a celebrity in Cambridge, and rumours of this wondrous instrument soon reached London. The Royal Society for the Promotion of Natural Knowledge had been started in London in 1660, and it's still going strong today, though most people just call it the Royal Society. In December 1671, Isaac let the Society see his new improved telescope, which was 5 times more powerful than his first. It was an absolute smash hit with everybody, including King Charles II, and Isaac was soon elected as a member of the Society. Almost immediately, the secretary of the Society got Isaac to write out his theories about light and colours. It went down a storm with just about everyone. Unfortunately, Robert Hooke was the curator of experiments for the Royal Society, and along with the Bishop of Salisbury and the scientist Robert Boyle, he was asked to check Isaac's findings in detail. Neither Boyle nor the bishop found any fault with Isaac's work, but at the next meeting, Hooke gave his reactions.
Newton's stuff is rubbish. I agree with Descartes. There are only 2 pure colours, scarlet and blue. All the other colours are a mixture of the 2.
Hooke's criticisms sent Isaac absolutely berserk. In the end, Hooke got a telling off from the Society, but Isaac's theories were also causing problems with scientists abroad. Isaac couldn't take criticism, and in December 1674 he threatened to give up philosophy and leave the Society. But he was one of the Society's biggest stars, and they begged him to stay. At the same time, Isaac was worried he was going to lose his well-paid Lucasian professor job because of his religious beliefs, or disbeliefs, to be more accurate. Cambridge was stopping other people from being fellows if they weren't ordained as priests, and so it was looking more and more unfair that Isaac had got away with it. A friend suggested that Isaac should approach the king for help, and Isaac was dead lucky. Isaac Barrow and Humphrey Babington asked King Charles II to let Isaac off becoming a priest.
Newton, isn't he that bloke who used to let me use his telescope?
And what's more, he used to draw your father's portrait on walls.
Oh, go on then.
So Newton kept his job. Encouraged by the support he'd been given, Isaac went on to give more details of his experiments with light. He even tried to get on better with Robert Hooke, and wrote a letter which said, "What Descartes did was a good step. You have added much several ways, and especially in considering the colours of thin plates. If I have seen further, it is by standing on the shoulders of giants." Although standing on the shoulders of giants is a great quote, and you'll even find it written around the edge of a £2 coin, you ought to know that Robert Hooke himself was rather stunted and physically deformed. Maybe this remark was Isaac's way of thanking everybody since ancient times, with the one exception of Robert Hooke. In the meantime, Isaac was getting more and more criticism from abroad, and he started to suspect that people were upsetting him deliberately. It wasn't long before he completely cracked up. "That's it! No more maths!" And by that he meant no more optics work either.
Isaac's odder occupations.
In 1673, Isaac and his university friend Wickens moved to some different rooms, which had a wooden shed attached to them. Isaac soon had lots of mysterious equipment bubbling away inside. And after he had decided to abandon science, he devoted all his time to alchemy. It's even been suggested that he thought of gravity while doing these bizarre experiments, and that he just made up the story of the falling apple for a laugh. The bad thing about Isaac's alchemy is that he used to make all sorts of strange potions and try them out on himself. This was very dangerous, because alchemy involved a great deal of work with the heavy metals, such as lead and mercury, which these days we know to be poisonous. Isaac would be happily breathing in the vapours as he heated them up, and even tasting the murky liquids they produced. One morning in March 1668, Isaac nearly burnt down his laboratory and his house. Notes from 20 years of his experiments and a massive book he had written about light were also burnt to ashes. Isaac didn't get over it for ages. Things got worse. Barrow had died the previous year, and in June 1679, Isaac's mother also died. Isaac was upset and confused, and to frustrate him even more, he had to spend the rest of the year sorting out the family.
Isaac gets a kick-start.
Back at Cambridge, in December 1679, a letter from Robert Hooke was waiting for him.
The Secretary of the Royal Society is now me. So there.
Hooke asked if Isaac could provide some mathematical answers to some questions about the movements of the planets. Hooke promised that anything Isaac sent would not be made public. So as not to offend the Society, Isaac sent a little fancy he'd had about how things fall out of tall buildings. Because the earth is spinning round, they don't quite fall straight down. Isaac said they fell in a neat little spiral. By a lucky guess, Hooke showed that the things fall in an elliptical spiral. He was so smug about this that he went back on his promise and told everybody. Isaac didn't contact anyone for a year, though Hooke kept writing to try and patch things up. In January 1680, one of Hooke's letters brought up the idea of a central attracting force, which held the planets in elliptical orbits and was linked to an inverse square law. Previously, the only gravity Isaac had thought about was when things were attracted down to Earth. But suppose the sun also attracted things by gravity. Maybe gravity could work at long range and reach right across space and hold the planets in their elliptical orbits. Whoa-hey! Hooke had reached a few conclusions of his own about gravity, but he couldn't possibly have done the maths to tie it all up. Isaac could, though. In 1684, Edmund Halley, a gentleman best known for predicting that Halley's comet would return to our skies every 76 years, paid Isaac a surprise visit and asked him to write up his findings. A few months later, 9 pieces of paper arrived at Halley's house. They were called De Motu Corporum in Gyrum, which is Latin for about the motion of orbiting bodies. When Halley first got the De Motu papers, he was so thrilled that he rushed back to Cambridge to see if Isaac had any more interesting papers that nobody else had seen. Of course, he had tons of them, and Halley offered to pay to have them all published. But Isaac wasn't ready just yet. While he had been preparing the De Motu papers, something awesome had occurred to him. If the sun has gravity and the earth has gravity, does everything have gravity? Isaac had started to understand the real implications of the big G, and he was starting to wonder whether this invisible force that worked right through everything in the universe could be the evidence of God that he had been looking for. God was supposed to be invisible, powerful, and everywhere, just like gravity. Isaac decided he would put all the solid facts he had together. If they were all going to be published, he wanted the result to be awesome.
The Big Book of Science.
Isaac worked on his great book solidly for a year and a half. Most of the time he was shut in his rooms, and his only company was his new assistant, Humphrey, who meticulously wrote the book out, word for word. Finally, in the summer of 1686, Philosophiae Naturalis Principia Mathematica was ready. Isaac knew it was going to be a monster classic. By the time Isaac had finished writing it, the Principia, as it was commonly called, ended up being not just one book, but three. The first book was basically his De Motu papers, reworked, and in April 1686 a handwritten copy was presented to the Royal Society. Edmund Halley took charge of it, and it's a good job he did, because without him it would never have been published. Halley abandoned his own work to make time to encourage Isaac and check what he'd written. He paid all the expenses and persuaded the Royal Society to put up the money to publish it. Principia didn't sell too many copies to start with, but eventually it became essential reading all over the world. Later in 1686, Isaac finished the second book. But as he came to finish the last one, he heard that Hooke was still rubbishing him to anybody who would listen and claiming Isaac had stolen his ideas. As a result, Isaac threatened not to publish the third book. In the end, he rewrote it. He had tried to make the first two books easy to follow, but now he arranged it so that you could only understand the third book if you'd already read the first two. He also made the maths as complicated as possible, just to make sure that Hooke had no chance of following it, or worse still, claiming it was his. So, what was the Principia all about? Forces. There, that was simple, wasn't it? Actually, the Principia was 550 pages long, so there was a bit more detail than that, but the two main things it says are: 1. The harder you push something, the faster it speeds up. 2. Everything is attracted to everything else, and the bigger and solider and closer things are, the greater the attraction. The most useful parts of the Principia are still used by engineers and physicists every single day, and they are known as Newton's laws of motion. Newton's first law says that everything stays still or keeps moving in a straight line at the same speed unless a force makes it change. So anything that isn't moving won't move until something gives it a shove. Easy. But anything moving will keep moving in a straight line at the same speed forever unless a force acts on it. Imagine you're riding in a car at a steady speed on a smooth, straight road. If you shut your eyes and block your ears, you will not be able to tell how fast you're moving. You might not even know if you've stopped. That's because there are no forces acting on you. If the car suddenly starts speeding up, you'll feel yourself getting pushed into your seat by the force acting on you. If the car suddenly brakes, the speed quickly slows, and you will feel yourself being thrown forward. Your seatbelt provides the force needed to slow you down too. For speeding up, slowing down, or turning a corner, there is always a force involved. Here's one more interesting thought about Newton's first law. If you throw a ball straight out in front of you, as it flies away, two forces will be acting on it. air resistance will gradually slow the ball down, and at the same time gravity will pull the ball down towards the ground. If it wasn't for these forces, then your ball could fly off in a straight line all the way to the end of the universe. Newton's second law says that the change in motion depends on how strong the force is. Have you ever tried to push a car by yourself? You have to push it really hard to get it moving, because the car is accelerating, which uses force. Once the car is up to the speed you want, you don't need to push nearly as hard. If you have another person to help, then the car will receive twice as much force, and you'll find it will build up speed twice as fast. On the other hand, if you're pushing two cars, then they will only speed up half as fast. Newton's third law says that to every action there is an equal and opposite reaction. Let's imagine two tug-of-war teams pulling on a rope. If they both pull with the same force, they don't go anywhere. If one team pulls slightly harder, the extra force causes the other team to accelerate towards them. However, if the other team suddenly lets go of the rope, the first team doesn't have anything to pull against, so they all fall over. All this was leading up to one dazzling grand finale. Isaac said that everything from the tiniest particle to the biggest star had its own gravity, and so everything was attracted to everything else. But how powerful was this attraction? He even came up with a formula which gives the attraction between any two objects, and claimed it applied to absolutely everything of every size in the whole universe. He called it his universal law of gravity. You could use it to calculate the force for a planet going round the sun, calculate the force of gravity on a rocket leaving the Earth, explain why pendulum clocks run slightly slower at the equator than the North Pole. Actually, it's because as the Earth spins round, it tends to bulge out a bit at the sides, which means that a clock on the equator is ever so slightly further away from the centre of the Earth. This means that gravity on the equator is a tiny bit weaker. Isaac had made a massive breakthrough.
Meanwhile, on the throne...
While Isaac was writing the Principia, all sorts of trouble had been brewing around him. In 1685, just as everybody had got used to having a Protestant on the throne, suddenly...
The Stuart Sun, February 1685.
King conks out.
Last week in Whitehall, King Charles II suffered a stroke and finally passed away on the 6th of February. It is rumoured that in his last hours he requested a visit from his old friend Father Huddleston, who converted the dying monarch to the Catholic Church in his final minutes. The king's brother, a strong Catholic himself, automatically becomes the new king.
James II.
King James was keen to see England become a strongly Catholic country again, and he used threats to see that Catholics quickly got top jobs. Isaac had never cared much for the Church of England, but he hated the Catholic Church of Rome far more. He spoke out against the new king and became involved in the Cambridge resistance. This was extremely dangerous. Early in James's reign, 300 rebels had been sentenced to the gallows, and the way Isaac was behaving, it wouldn't have been long until his turn came. Luckily, people quickly got fed up with James, and he fled the country. In 1688, the Protestant William of Orange took advantage of this and sailed over with an army from Holland. William and his wife, who happened to be James II's daughter, jointly took the throne in 1689, which was a bit of a result for Isaac. He was invited to join Parliament as MP for Cambridge University. Isaac was MP for a year, but he only made one speech. "There's a bit of a draught. Can you close that window?"
At last, some new friends.
During his time in London, Isaac made a few friends. Christopher Wren, famous architect, John Locke, famous philosopher, Samuel Pepys, famous diarist, and William III, famous king. Then there was Nicolas Fatio de Duillier. He was a Swiss mathematician who hero-worshipped the top academics and thought Isaac was particularly great. In return, Isaac was very taken by this clever and keen young man, and the two of them became very close. Fatio encouraged Isaac in the spookier side of his investigations. Isaac was trying to follow up Principia with something that would bring alchemy and religion all in line, in the same way as he'd sorted out gravity. He would have loved to publish a book showing that the Christian way of following God was all wrong. But unless Isaac could find absolute proof, he would be branded as a heretic. So these studies had to be as secret as ever. Sadly, this friendship didn't last, and after Fatio left, Isaac lost his inspiration and the nerve he needed to carry on his work. Of course, without his work, Isaac had nothing. And after this point, he didn't do any more maths or science. Yippee! Meanwhile, he became even meaner and horrider than he already was. In September 1693, he started sending strange and unpleasant letters to some of his London friends, who luckily had the sense to realise that Isaac was seriously ill. They thought he needed a new start and asked him to become president of the Royal Society, but Isaac absolutely refused.
Because I, Robert Hooke, was still the secretary.
However, Isaac's old friend, Charles Montague, had just been given the job of Chancellor of the Exchequer, and one of his departments was the Royal Mint, where all the coins were made. Montague offered Isaac the job of Warden of the Mint.
The Forger's Nightmare.
All Isaac had to do as warden was turn up to a few meetings and pocket the wages, which could be anything up to £2,000 a year. That's pretty good pay, when you realise it's the equivalent of £1 million a year these days. But Isaac wasn't the sort just to sit about and pocket the cash. And at the Mint, he found a completely new sort of challenge waiting for him that he couldn't possibly resist. British money was going through a crisis. About 1 in 5 coins was a fake. Half of the real coins had been clipped, which means tiny bits of gold or silver had been snipped off. This would be melted down and sold. Foreign countries were starting to refuse to accept English coins. If these problems weren't overcome quickly, then England would have gone bankrupt and the monarchy could have been overturned, and this would have meant the return of the Catholics. Isaac quickly took over the running of the Mint. To try and solve the money problem, the Mint had already started making a completely new set of coins which were harder to fake. They had little grooves round the sides, which made it obvious if a bit had been clipped off.
The Stuart Sun, August 1696.
All change at the Mint.
The Warden of the Mint has designed and installed new machines that produce coins 8 times faster than before. 300 men and 50 horses are employed from 4 a.m. right through until midnight, producing well over
£100,000
of new money each week. An exhausted worker says,
I just work 1 10-hour shift and that's enough. Sir Isaac sometimes works right through the whole 20 hours. Oh.
Sir Isaac, 51, was not available for comment.
Apparently,
he was at work.
Even though forgers could be punished by hanging, there were lots of people so poor that the temptation to make a few dud shillings was too much to resist. Or it was, until Isaac came along. He decided to go out and bring the forgers in himself, and he visited all the nastiest, seediest and dirtiest dives in London to dig out his culprits. And once he turned his mind to the job, Isaac started to get rather good at it. With his haggard face, silver hair, hawk eyes, and awesome rage, he could reduce the toughest nuts to mumbling jellies. Hundreds of forgers were thrown in jail, and Isaac even signed the death warrants of the dozens who were hanged. Criminal society just didn't know what had hit it. There was one major forger, William Challoner, who lived rather grandly in Kensington. He claimed to have invented his own money-minting machine, and even suggested Isaac's machines were making forgeries. If Challoner thought his allegation was funny, he'd made a big mistake. Isaac started investigating Challoner, and soon realized that he was a big-league counterfeiter. Isaac went all out to finish Challoner off, using bribery, intimidation, and anything else it took to get the facts he needed. When Isaac finally presented the case against him, it was absolutely concrete. In 1699, Challoner was hanged, drawn, and quartered at Tyburn.
Isaac's spare time.
For Isaac, every day had 24 hours, and very few of them were to be wasted on sleep. One little diversion, from sorting out the country's coins, came from the German mathematician Leibniz, who'd thought of a problem concerning gravity. Both he and his Swiss mathematical mate Bernoulli were completely stuck on it, so they challenged anybody else to come up with an answer. When a copy of it reached Isaac, he decided that he refused to be teased by such silly puzzles. But the temptation was too much for him, and by the time he started work at 4 a.m. the next morning, he'd written out the solution. He sent it off without signing it, but Leibniz knew immediately where it had come from. Isaac became master of the mint in 1699, and kept the job for the rest of his life. In 1701 he resigned from being the Lucasian professor and had another year as an MP. During this time he started releasing papers describing some of the early scientific work that he had kept so secret. Then, in 1703, Robert Hooke died, and Isaac finally accepted the presidency of the Royal Society. The very first thing he did was pull down Hooke's portrait from the wall and have it burnt. The society had got rather lazy over the previous years, and this wasn't Isaac's style at all, so he decided to make the whole thing more exciting again. He arranged that every meeting should have a practical experiment for members to see. He even released all his findings on light in his great book, Optics. He also published his Fluxions, which led to a titanic clash with Leibniz, who'd published his calculus 20 years before. The two mental heavyweights made each other ill with accusations and abuse, and even after Leibniz died in 1716, Isaac never missed a chance to write or say something vile about him. What with arguments, publications, demonstrations, burning portraits and everything, the society became a happening place again. Isaac must have been one of the main attractions himself, as the broody but brilliant president, and in 20 years he only missed 3 meetings.
Oyez, oyez! Hear all about it! King falls from horse and dies of injuries!
Yes, indeed. In 1702, Isaac's friend William III fell to earth, then left it to join his late wife Mary. The throne went to her sister Anne, but the new queen had a difficult time trying to get everybody to support her. She started handing out honours to influential people, and obviously Isaac, as president of the Royal Society, master of the mint and greatest scientist ever known, was high on her list. In May 1705, he was knighted. Even in his 70s, Isaac was still keeping himself busy with both the Royal Society and the mint, and he was still sending forgers to the gallows. Leibniz tried to catch him out again with another fiendish puzzle, but as before, Isaac sat up all night to solve it, then went into work as normal. Isaac also tried redrafting some of his religious beliefs to see if he could present them in an acceptable way, but it didn't work. All in all, life cruised on rather unspectacularly, apart from a couple of rather confusing books he wrote. The first, Chronology of the Ancient Kingdoms Amended, was such a crazy mixture of astronomy, scripture and maths that hardly anybody understood it. His very last book wasn't any better. Observations on the prophecies of Daniel and the Apocalypse of St. John was a very dreary read based on the Bible studies he'd been making for 50 years. The most interesting thing in it is that Isaac reckoned the world would end in the year 2132. So put it in your diary. Both books were so odd that neither of them were published until after Isaac had died. When Isaac finally started to get frail, it happened quickly. He kept his spirits up to the end, but in the early morning of the 20th of March, 1727, he died. For Isaac, dying must have been the ultimate experiment, in which he would get the final answer to the biggest question of all. Where is God?
After Isaac.
Isaac's body was buried in a grand ceremony in Westminster Abbey on the 4th of April 1727, but his work will survive forever. So, did he get everything right? The answer is yes. Well, maybe not quite everything. But when you think that Isaac completely changed the whole way we understand science, any little corrections we try to make seem rather pathetic. In fact, after 300 years, we've only found a few details that can be improved. Albert Einstein got concerned about what happened when things travelled at the speed of light and eventually realised one of Isaac's equations needed a little tweak. But unless you're travelling at several thousand kilometres per second, Albert's alteration won't make any difference at all.